I think that the key milestones that PASQuanS2 has achieved, the most important for the future, is building a solid community that is collaborating at all levels in Europe to build and develop the next generation of quantum simulation with neutral atoms. We have a full stack involved. We have already 2 very productive and fast developing startups that have spawned from PASQuanS in the early stage. Pascal, one of our European champions in these technologies. Next, some years later, we have Planck, the German startup that is following the same path.
We got the systems bigger, we got the systems better under control. And now it's the question on practicability, to bring the current capabilities, or let's say near future, midterm capabilities together with interesting applications from the industry side.
I see 2 values that quantum simulation bring. First, we are now at a point where we can really implement interesting problems with quantum simulation on our systems. We can explore problems in condensed matters, for example, with magnetic materials, in a very relevant way, where we can bring value to external users that are not used to quantum computing. That's the first value. And second, quantum simulation paves the way for investigating other types of problems, using the same type of tools, using the same hardware, but more general problems, like using analog computing to address optimization problems, machine learning problems. Quantum simulation is really the first step in this direction.
As quantum technology engineer is a complex branch. I think the gaps are various. However, one that is the most relevant is related to bridging the gap between a laboratory prototype and industrial products. This do not mean only to increase performance. It is one of the main goals in this context, but is also related to robustness of the solution, fidelity of the solution, and create a standard. Standardization is fundamental, altogether with the insertion within the market supply chain. Altogether, fundamental is the increase of quantum resources that will enable directly a novel solution in satellite Earth observation system.
By the end of the decade, when PASQuanS 2.2 is planned to finish, we think that we will have complete the transitions towards having machines that are ready to be applied in the industrial settings. And of course, there are also academy settings on the side, which will allow to explore even more futuristic ideas. This will become a tool which will be normal to be used, exactly as now we are using quantum computers. Of course, they are still limited. Even in 3 years, they will be limited, but that's exactly what happened for classical computers. 40 years ago, they were limited, but science and industry started building on that and following third development for the years to come. That's exactly what we want. We want a Europe ready for the new decades of developments, which will be based also on quantum computers and quantum simulators.
Actually, this will be the prime target of the upcoming second phase, SGA2, where we want to merge the things and hopefully demonstrate a practical quantum advantage, which is, of course, the golden goal of all quantum technology, or quantum computing and quantum simulation together.